Hi! I was just looking up at our space mural, wondering if there are any other habitable planets out there in the vast universe. Do you know the story of Goldilocks and the three bears? She finds a house while out on a walk, knocks on the door, and no one answers. Inside the kitchen are 3 bowls of porridge. One is too hot, one is too cold, but one is just right. The same thing happens with 3 chairs and the 3 beds. The 3rd chair and the 3rd bed were just right. Scientists are looking for that just right fit, a Goldilocks planet, in their search for distant Earths in the Milky Way galaxy and beyond. These planets are known as exoplanets and are the topic of this Cerritos Library Universe of Learning virtual program. Join me as we explore the book Exoplanets by Seymour Simon. Planets found circling stars other than our own star, the Sun, are called exoplanets. In the last 20 years, scientists have found thousands of exoplanets circling more than 2,000 distant stars. Many planets are unlike any of the planets in our own solar system, but some are Goldilocks or habitable exoplanets similar to Earth where we might find alien life. Our Sun is just one of at least 100 billion stars in the Milky Way galaxy, a barrel spiral galaxy about 100,000 light years across. The stars in the Milky Way galaxy are in a pinwheel pattern with 4 major arms, and we live about 2/3 of the way up one of the arms. Many, if not most stars, host their own families of planets. Based on observations, scientists predict that there should be about 1 Goldilocks, Earth-sized planet in the habitable zone of each red dwarf star. Other stars, more similar to our own Sun, might have even more habitable planets orbiting them. At first, astronomers searched for exoplanets around stars like our Sun. However, the first confirmed discovery of an exoplanet was around a pulsar called PSR B1257 plus 12. A pulsar is a rapidly spinning dead supernova, a star that has exploded. The next discovery of a planet orbiting a star like our Sun was 51 Pegasi b, a Jupiter-sized world 20 times closer to its Sun than Earth is to our Sun. In the mid-1990s, the only exoplanets that could be detected were very big, much bigger than Jupiter, the largest planet in our solar system. One of the early ways astronomers looked for exoplanets is called the radial velocity method. They looked for a small wobble in a star that might be caused by the gravitational pull of a planet orbiting that star. While many planets have been found this way, it only works well for very large Jupiter-sized gassy planets. These planets are very unlikely to have life unless they have a habitable moon. In recent years, scientists have begun using the transit method to find exoplanets. This method looks for slight dimming of a star that would be caused by a planet crossing in front of it. Using this method, scientists look for Earth-sized planets and also for gases, such as water vapor, which might show the possibility of life. There are several thousand exoplanets that have been discovered by a single telescope using the transit method. The Kepler telescope went into orbit around the Sun in 2009 and has confirmed more than half of the known exoplanets to date. It has also spotted over 4,000 more waiting to be confirmed. The telescope named for the famous astronomer Johannes Kepler was designed to look for possible habitable planets. Besides a variety of gas giants and Earth-like planets, Kepler found a new category known as super-Earths. These are planets that are between the size of Earth and Neptune. Some of these super-Earths are in their solar system's habitable zones, and scientists are studying how life might develop on these giant planets. A few years after Kepler was launched, it stopped working because of a malfunction that prevented it from pointing at a star without drifting off course. Scientists found a way to get Kepler back online by using the pressure of sunlight to steer the spacecraft so it could continue to explore. Its new mission, K2, is providing even more results. Thanks to the Kepler and K2 missions, scientists now know there are probably more planets than stars in the galaxy. The Transiting Exoplanet Survey Satellite, known as TESS, is the newest planet hunter and also uses the transit method by finding exoplanets that periodically block part of the light from their host stars. TESS was launched April 18, 2018, aboard the SpaceX Falcon 9 rocket and is looking for planets from Earth size to Jupiter size. It will survey the entire sky for 2 years using its 4 cameras. Scientists expect the mission will catalog thousands of planet candidates and vastly increase the current number of known exoplanets. An even newer method used to find exoplanets is called direct imaging. This involves photographing the planet directly. Scientists must use an instrument to block the light from the star, which then reveals the dimmer light reflected by the exoplanet. In 2008, scientists announced the discovery of Fomalhaut b, an exoplanet imaged in visible light. On the same day, another team of scientists using infrared light announced the discovery of a solar system of 4 planets circling a star. Since then, direct imaging has been used with earlier methods to explore for new exoplanets. Exoplanets come in a variety of sizes and distances from the stars they orbit. Some are icy and circle far from the sun they orbit. Others are rocky, like Earth and the inner planets of our solar system. Proxima b is a rocky planet in the Goldilocks or habitable zone. It orbits Proxima Centauri, the closest star to our sun. Even though it is the closest exoplanet to Earth, it is still 4.2 light years away. Scientists are working to create an ultra-fast spacecraft that would reach the planet 20 years after it is launched and then beam home images. In our solar system, the planets circle one star, the Sun. But there are many solar systems that have 2 or more stars at the center. 91 Aquarii b is an exoplanet that is part of a triple star system. About 40 light years away from Earth is the TRAPPIST-1 system. It contains 7 Earth-sized planets that orbit a dwarf star. 3 of the planets are in the habitable zone. Most of the planets are also rocky, like Earth. The planets are close enough for them to find out if they have atmospheres and water on them. We know that the galaxy is teeming with exoplanets, many of which are Earth-size or super-Earths, and appear to be orbiting their parent star in the habitable zone. However, each star has a different habitable zone. Stars that are more massive than our Sun are hotter and blaze with radiation, so the habitable zone is further out. Stars that are smaller and cooler have habitable zones that are closer and tighter. It turns out that many exoplanets are more similar to super Venus-like planets rather than super Earth-like planets. Kepler 69c is one of these super Venus planets. This planet that is a bit less than 2 times the size of Earth and lies just inside its sun's habitable zone, making it too hot to sustain life. The habitable zone of a star also depends on the chemistry of a planet. For example, some kinds of gas molecules in a planet's atmosphere will absorb a certain amount of sunlight and radiate the rest back into space. How much energy is absorbed could mean the difference between an ocean of water and a sea of boiling lava. NASA's James Webb Space Telescope that is planned to be launched on October 31st, 2021 will help astronomers learn more about Goldilocks planets, their atmospheres, and if life can thrive on them. Gliese 667c, a super-Earth, can be found orbiting in its red dwarf star's habitable zone. The planet, at 4.5 times the mass of Earth, orbits its sun in only 28 days. If the planet has liquid water on the surface, the temperature would be about 90 degrees Fahrenheit. That could allow for life, but right now, no one knows for sure what exists on the planet. Kepler 442b, Kepler 438b, and Kepler 62f are 3 exoplanets in the Kepler system that orbit a red dwarf star that is smaller and cooler than our own sun. So is there life on other planets out in the vast universe? In 1974, Frank Drake created the Arecibo message, a simple broadcast sent into space by the Arecibo radio telescope in Puerto Rico. The message encoded several things in binary form, which is a computer way of speaking. The message included the numbers 1 through 10, the basic chemistry of life on Earth, the double helix structure of the DNA molecule that is in all life on Earth, Earth's human population at the time, a graphic of the solar system, a human figure, and a graphic of the Arecibo radio telescope. We don't know if any life form has received the message, and so far, no one has replied. So what are the chances of life on alien worlds? Many astronomers believe there is probably some form of life on other worlds. However, there are many unknowns that can't yet be answered. One reason is that even the closest stars are very far away from Earth. Traveling at the speed of our spaceships today would take tens of thousands, maybe even hundreds of thousands of years to reach the nearest exoplanet. Imagine what it would be like to travel to these exoplanets. NASA scientists and artists have designed a series of travel bureau posters imagining what these planets might be like to visit. Some have steaming oceans of lava. Many would be close enough to each other to see other planets close by. Other exoplanets would have multiple sunrises and sunsets to enjoy. No one knows how many of the exoplanets could support life or if they even have simple microbes. This unknown continues to drive our curiosity about our world, space, and the universe. Our quest for knowledge continues, and you are a part of that journey every time you look up at the night sky and wonder. You can use NASA's Eyes on Exoplanets app on your computer to explore new worlds by going to eyes.nasa.gov. Thank you so much for joining us for the Cerritos Library Universe of Learning virtual program. Next, Miss Rochelle has some special crafts to do with you guys, so stick around. Bye, guys.
Hello, everyone. My name is Miss Rochelle. Today we'll be creating a cardboard rover, a straw rocket, and an exoplanet rock. Join me in the art studio and we'll get started. The materials you'll need for the straw rocket are a pencil, straw, tape, scissors, measuring tape, and the rocket template and data log that can be located at Cerritos Library Universal Learning Virtual Programs webpage. The first step is to cut out the rectangle and fins from the template. Once you do so, you will have this. Next, wrap the rectangle around the pencil and tape it so it forms a tube. Make sure you do not tape the rectangle to the pencil. Tape the fins to the bottom of the rocket. The fins should be opposite sides from each other. Bend each fin unit so they are 90 degrees from each other. The fins should form a plus sign when you look at them from the bottom. Twist the top of the rocket into a nose cone. Tape the nose cone. Once your rocket is complete, you will remove the pencil and replace it with the straw. Now you're ready to launch your rocket. Make sure you launch your rocket in a safe area away from people and hazards. Now your rocket is complete and you can record the distance your rocket traveled on your data log. The materials you'll need to make an exoplanet rock are a flat rock, acrylic paints, popsicle stick, and paper plates. The first step is to place a clean, dry rock on a flat surface. You might want to use paper plates, newspaper, or construction paper for the painted rock to dry on. Next, you will need to pour a small amount of acrylic paint on a paper plate. You can use 2 to 4 colors for each rock. Make sure you put the paint next to each other and not on top of each other. You will now use a popsicle stick to create a swirl in the paint. Slowly dip your rock into the paint and press lightly on the rock. Lift your rock out of the paint to see your newly designed exoplanet. Make sure you let your rock fully dry for a few hours. Now your exoplanet rock is complete. The materials you'll need for the cardboard rover are a 6-inch square of corrugated cardboard, 2 5-inch squares of corrugated cardboard, a ruler, a sharpened pencil, a straw, 2 pieces of round hard candy with a hole in the center, scissors, 2 rubber bands, and tape. To make the rubber body, you will need to fold the cardboard into thirds. Make sure you fold along the corrugation. Each section will be about 2 inches across. Next, we will make the wheels. You will need to take both 5-inch cardboard squares and draw diagonal lines from each of the corners, forming an X. Poke a hole in the center where the lines meet. Next, we'll put this aside. Now we will attach the rear axle and wheels. Use a pencil to poke a hole near the top of each of the 2 outermost sections of the rover body. The holes should be directly across from each other and big enough for the pencil to spin freely. Slide the cardboard wheels onto each end of the pencil and secure them with tape. To make the front axle and wheels, you will need to tape the straw across the bottom of the rover body on the opposite side from the pencil. Then slip a piece of candy onto each end of the straw. Bend and tape the ends of the axle to prevent the candy from falling off. The next step is to create a rubber band chain. Now we're going to cut small slits in the front end of the rover body. Now we will need to loop one end of the rubber band chain around the pencil. Then attach the other end where the slits are. Now your cardboard rover is complete. To power the rover, you will need to turn back the wheels to wind the rubber band around the axle. Thank you for joining us for our program about exoplanets. We hope you had a great time watching. Bye-bye.